Here is the first part of our module 3 review. So, factor each completely. Remember, whenever you're factoring, you first need to find the greatest common factor if one exists. And even if one does exist, you need to keep factoring from there. Number one, you can factor a 3 out of each of those terms. In other words, a 3 can be divided equally, or can be divided out of all 3 terms. So that 3 goes out in front, and then in the parentheses is what remains. So when you divide the first term by 3, you get n squared. When you divide the next term by 3, you get negative 8n, and the last term is 7. Now, I always try to factor completely. Now I have a trinomial, or I still have a trinomial, but it's looks like that now. Try to factor that even further. And so when your leading coefficient is 1, because now it is a 1, I've divided that 3 out, you look for ways to multiply to 7 and add to the b value, which is negative 8. And negative 1 and negative 7 work here. That means that I could rewrite this with the GCF out in front, and I could rewrite that trinomial as n minus 1 times n minus 7, or 3 times n minus 7 times n minus 1. These factors can get multiplied in any order, but the GCF is usually right out in front. Number 3, factor completely. Oh, those numbers are huge. And so if we did the a greater than 1 trinomial factoring method, that would be really tough. It'd be possible, but it'd take a long, long time. So look, let's get a GCF factored out. So then we get n squared minus 15n, 56. You can always use a calculator on that, folks. And so now we're looking for ways to, look, we have a 1 as our a value in front of the n squared. That's great. So we're just looking for ways to multiply to 56 and add to negative 15. And so here it would be a negative 8 and a negative 7. So this can get factored as n minus 8 times n minus 7. Don't forget to bring the GCF down. So each of these 3 parts right here, folks, here, here, and here. These are, let me change the color. Here, these are all factors of this original polynomial, or trinomial up here. There we are. Let's try one more. 6, I believe, goes into all 3 of these numbers on number 5. So we factor a 6 out, we're left with a squared plus 2a minus 24, I want to say, yeah, 24. So look, my new a value, or coefficient of the a squared term, is 1. That's great. I'm looking for ways to multiply to negative 24 and add to 2 now. Add to a positive 2. That'd be positive 6 and negative 4. That seems to do it. So in other words, what I have written, that trinomial up above, could really be written as a plus 6 times a minus 4. And if you FOIL this all together, folks, you'll see that if you multiply these terms together, you do get what's up there. And then if you multiply 6 into these 3, you get what's there. Don't forget to bring your 6 down for your final answer. So factoring is really like dividing a polynomial out. If I multiply all 3 of these things together, I get that. These 2 things are equivalent, but what's down below is factored form. And that's what we're going for right now. We'll see larger connections to that